Here the consistency property of OLS estimators are defined. An estimator is said to be consistent if it follows these two properties. That is, an estimator must be unbiased and variance tends to 0 as sample size n tends to infinity. That is, this is the second property. The estimator must be biased. Not only that, variance must be tend to 0 as the sample size n increases or it tends to infinity. The first property is it is unbiased. The unbiased property says that the expected or the average value equal to beta 2, that is beta 2 cap equal to sigma xi yi by sigma xi square. This is equal to sigma of ki yi. Then substitute yi equal to beta 1 plus beta 2 xi. Then multiply the whole term by the ki. Then use the equation sigma ki equal to 0, sigma ki xi equal to 1. Then the equation, this term will be 0 and this term will be 1, and therefore beta 2 plus sigma ki ui. That is the expected value beta 2 equal to the true value. This is the unbiased property. Second one is variance tend to 0 as n increases. Variance is given as sigma square by sigma xi square. Dividing the numerator and denominator by n, that is sigma square by n divided by sigma xi square by n, and then take the limits of this function. Then limit of this function equal to limit of this function divided by the limit of this function. Limit of this function tends to 0 as it's the constant, and this sigma xi square by n also tends to 0 or it is not equal to 0. Then this whole terms will be equal to 0. This is the consistency property of the least square estimate.